Hello, folks, and welcome to another episode of Atom, or A Touch of Multiplatform. Today we are joined by Max from Lutron, a very cool person from a very cool company. My name is Justin from Touchlab, and I once took down my team's Git server by accidentally committing some very large binaries. I'm here with my co-host Pamela. Hello, Pamela.
Hi, my name is Pamela and I'm a developer advocate at JetBrains. So my claim to fame is in 20 years that I was working as a developer, I only took down production one time. Max, please introduce yourself.
Sure. Yeah, so my name's Max. I'm a reformed data scientist. I did math for many years, got into data science, but I think I just liked all the coding parts of data science the best. So I guess about 7 years ago, I decided to switch careers and just do software engineering. And I've been at Lutron for 5 years now, and I'm loving it.
Great. So Max, are you a coffee or a tea person, or not undecided, or
mainly tea?
Yeah.
I do coffee though.
Okay.
That's fine. I try not to be too addicted to caffeine. I try.
Yes, yeah. I'm also a tea person. You can't see inside my mug, but that is tea in there.
So we have a particular South African blend. I don't know if you've heard about it, Rooibos or Red Bush or something like that. Yeah. So that's a South African tea.
Oh.
Very sweet, very naturally sweet and so on. But I don't know if that's maybe your favorite blend, but that's from South Africa.
No, I'm much more of a chai person myself, like the black tea. Yeah.
With the spices. Nice. Yeah. Mm-hmm. Yum.
Yep. So going into technology, how do you keep yourself up to speed with all these updates? Technology moves fast.
Yeah. I'm definitely very into technology. I do a lot of tech stuff in my spare time. So I'm on a whole bunch of different like subreddits, just kind of seeing what people are talking about, the latest technology. But I also just love learning new tools. So I'm the kind of nerd who will like learn a new programming language for the weekend. So that helps a lot, that I just like find it really enjoyable to learn about new stuff. So I'm always kind of on the lookout through various news sources and stuff like that.
Now I need to know what's the newest weekend programming language.
Lisp, actually.
Ah, a classic.
Yeah, it is. It's a classic, but I somehow missed it all these years, and so I felt like that was a gap. So I did. Can't remember the name of it, but there's basically someone had implementing Lisp in Python, your own Lisp interpreter.
Okay.
And I actually like Ruby a lot more than Python. So as a challenge, I implemented Lisp in Ruby. It was pretty fun. I enjoyed that.
Okay. Start telling JetBrains they need to add more parentheses to Kotlin.
That's right. Yeah. I as a joke, as a joke, we have like a whiteboard for like our whole Kotlin design, and the thumbnail of it says "Rewrite app in Lisp," and it's just an arrow pointing at itself because Lisp is all about like metaprogramming. So I really like that.
Cool. So you work at Lutron. Tell us a little bit about it as a company. I'm not familiar with it. Is it international or?
Mm-hmm. Yeah, we don't advertise ourselves well. So yeah, we're an international company. We're sort of like we're a lighting control company. We make lighting controls, and we are sort of like the high-end luxury tier, kind of internationally recognized. So if you're in a really fancy skyscraper or a really fancy museum or a really fancy house, chances are they've got Lutron. That's the kind of stuff that we try to make.
So you're saying that my house isn't fancy?
Well, we also have like DIY stuff. You can go to like a hardware store and get Lutron, but even then, it's gonna be the more expensive stuff in the hardware store.
Okay. Yeah. So what kind of problems do you try to solve at Lutron?
Yeah, so it's a lot of supporting new hardware. We started off as like just a hardware company. little fact, our founder invented like the modern dimmer for lights. Joel Spira. So before him, dimmers used to be like really impractical and nobody liked them, but he made a really nice one, and that's like what all dimmers use now. He has the patent on that.
That's nice.
So for many years, we just only made various lighting control hardware, but these days it's all about having these like integrated systems where you can have like programming and logic and monitoring and data usage collection and stuff like that. And so we're always making new hardware, and then there's this endless challenge of just how do we incorporate that hardware into our existing systems and take advantage of all the cool functionality of that hardware and expose that to the users so they can, understand it and control it and interact with it in all these different ways.
Mm-hmm. And your team, what does the structure look like basically?
Yeah, we have a really nice kind of open, flat structure. Very agile, I think in the true sense of the word. We're totally self-organizing. We just have a big pool of software engineers, and we kind of move ourselves around as we need to in order to best solve our problems. So currently, my actual team is actually just me and one other person, and we're purely focused on solving these like fundamental architectural problems. But at the same time, I am part of like the larger just mobile app development team at Lutron. So I kind of move between different groups, helping them solve these more like tricky technical problems that they might face on the various features that they're developing.
Mm-hmm.
So in the self-organizing, the teams and the autonomy that you have, is that purely around the software decisions are you making, or can you just gift us like Lutron devices if you want to?
Unfortunately, mostly around the software teams.
Well, in terms of the software choices, you are using KMM. You're on the show because of that.
Mm-hmm.
How did you come across KMM?
So it wasn't me personally. Actually, it was another engineer who found it, and we were looking for cross-platform functionality for our mobile apps because we had these completely separate iOS and Android apps, and the burden of developing them was becoming like really annoying because both teams were separately growing, and it was just like, this is not scalable to multiply everything by 2. So we actually researched several different technologies because we saw this was like beginning of 2021. At the time, there were even options available like for basically any language. You could actually cross compile for like Android and iOS. So we looked at several of them. Kotlin Multiplatform Mobile was in the mix there, and we tried to evaluate them somewhat objectively, and that Kotlin Multiplatform won. So that's the one we picked to start with. And it took a while to actually like get from there to like success, but that's how we found it.
I'm curious about your initial thoughts, since you weren't the one who found it first.
Yeah.
How did it come to you? What did you think? Were you skeptical about it in any way?
Definitely, yes. So most of my experience was with iOS specifically, and so Kotlin was a total unknown to me. I'd never looked at it at all, and it was also very new at the time. At least I'm not sure how you feel about that, but at the beginning of 2021, we felt it was still very early. I actually just looked up, like we had like a scorecard for all the languages we were evaluating. And it's kind of funny. We ranked Kotlin last for life expectancy. For Kotlin Multiplatform Mobile, we were like, okay, how likely are these languages to succeed in the long term? And we thought there was no chance for Kotlin Multiplatform, apparently. So, and that was definitely a little bit of my opinion. I was like, this seems really risky. But basically, the other aspects of it were nice enough. Like, definitely there was the big safety net of like, hey, even if this works out, we can probably salvage all this for our Android code. It's not going to be a total loss. So I think that was, and also just like that there did seem to be a lot of like community around Kotlin in general. So we're like, hey, at the very least, it'll be easy to learn this. It'll be relatively quick to onboard. So I think those were the factors that sort of, I don't know, assuaded my fear a little bit, and enough to try it out. And once we started using it, it was like, oh, this is great. Like we're going to bet on this.
That's very cool. So your journey with KMM started with just your frustration with duplicating code all the time.
Yeah.
And then you started investigating different technologies like Flutter. I assume you looked at Flutter and React Native and all those kinds of technologies. But in the notes that we sent, or that you gave us earlier, you mentioned that you started with a KMM project and then that project failed, and then you sort of started with a new project and it's going really well. Tell us a little bit about Lutron's journey in that respect.
Sure. So things like Flutter and React, we did briefly consider those, but those we actually eliminated really early on. We really like having more lower level support. We didn't like the idea of something where it's like this whole framework on top of mobile and we're kind of stuck in that framework, because we've tried things like that in the past and gotten bitten. So we like things that are more just like closer to how the native app development would work. And it seems like Kotlin Multiplatform had that aspect. Like the fact that you get like an Objective-C looking library was really nice. But yeah, our first project, this was like a totally separate thing. That at the time we had this whole like testing initiative where we were trying to find better ways to do automated tests of our software for better quality control. And so we came up with the idea, like, I guess I didn't really mention this so specifically. Since we do lighting control, we do a lot of smart home stuff. So our app is particularly challenging because most of the functionality of the system, I mean, really all the functionality of the system is not in the app. It's not in the cloud. It's actually in like a little smart hub in your home. And so most of the functionality of the app that we care about testing is like, how are we communicating with that hub? And is that communication going well? And so that's always very difficult for us to test. We do a lot of testing with real hardware. Like all of our engineers just have tons of like random hardware around on their desks so we can actually test with the real stuff. But it's very slow and expensive to do that. So the initial idea was like, oh, can we make sort of a library, a cross-platform library that acts like one of our smart home systems? And so the app can kind of talk to that library to do like end-to-end integration testing. It was a very, I think, ambitious plan, and that's kind of why it failed. It was like something we had never really done before. It was almost really a proof of concept. And if you look at how people want to do testing normally, like kind of that end-to-end testing is usually one of the least important things. It's more like, oh, you should really be focusing on unit testing. So ultimately, we're just like, okay, let's do that. Let's focus more on unit testing. So we don't need this whole library project. But in doing it, we at least got Kotlin Multiplatform working. We got to play around with it. We saw what it could do. And from that, I was like, I think I can take this and make a new sort of architecture for our mobile apps that we could use just to develop like our mainline features that our customers use. And so I took that, and my preferred style of doing these kinds of big architectural changes is I always like attach them to a feature that people want. So that way no one can tell me no. It's like, well, we're using this for the feature. So if you want the feature, you have to let us do this Kotlin multi-platform thing. So that was one of those things where like I kind of left my team and I like joined that team. I was like, all right, I've been studying this Kotlin multi-platform thing. I think it's going to be great. Here's how you're going to use this to develop this feature. And that's what we did. And that worked. And from then it was just kind of going around to every other team where it's like, hey, look, that team did this cool thing. You should do it too. And kind of recruiting them one by one.
Mm-hmm.
Yeah.
I think a lot of times, like with Kotlin, a lot of times it has to do with the story that you tell. Like it was back in 2019 when we had the closing panel, I was thinking about how people come to conferences and they pick up stories from different people, and like success stories, failure stories sometimes. But that's basically how people learn socially about what technologies work and what don't work. And I think that what you experienced, maybe the first attempt didn't go so well because you went too big too fast. Mm-hmm. But maybe the second time around, you had the knowledge of, taking things a little slower, and you had the pre-knowledge of knowing what basically how it worked, and it was a lot smaller kind of technology that you had to get used to, the amount of technology that you had to get used to. So
Right.
I really like that story. It's a really good, it's a keeper. Mm-hmm.
Yeah. I mean, I can go into way more detail about this stuff, but like it was definitely not easy, even that first thing. Like we definitely had to do a lot of new stuff that we hadn't done before, even when it was just like, okay, this one feature, like the kind of feature that we're kind of used to. It wasn't like a really wild and crazy thing. It was like, oh, there's like a typical feature for us where we're like supporting a new piece of hardware. And I was like, oh, how do you feel about this being like twice as expensive? Because we're going to have to figure out this Kotlin multiplatform thing at the same time. But I don't know, luckily people believe me, like it'll pay off in the long run. So we were able to put in that upfront investment.
Yeah, that's great. What do you think you learned from all of this? And what did you do better the second time around and the third time around and so on?
It's definitely there have been a lot of lessons about just how to focus your software designs in a way that like they're going to deliver the most value to you. Like we saw a lot of examples on like, blog posts and stuff about how people were using Kotlin Multiplatform. And some of those were useful, but some of them did not really apply to us. And there was a lot of cases where we kind of started off doing things like probably too naively. And we had to kind of go back later and be like, that's actually not a good idea for us. And that's where it's been helpful to have my team, which is like this architecture team, where it's like, we're not focused on features. We can kind of go back after the fact and say, ooh, this was sort of a mistake we made with Kotlin Multiplatform, but we can kind of clean it up now that we know better. And that's been really helpful to incorporate these lessons back into the code base rather than just like accumulating a huge pile of technical debt, because that definitely happened. We have already a huge pile of technical debt from Kotlin Multiplatform just because it was a new technology to learn. But that's okay, because we're still moving forward. We're still delivering value to our customers. And we value as a company going back and paying off that debt quickly rather than just letting it sit forever.
You have a very interesting perspective as an architect, as someone coming from iOS. Thank you for being straightforward with us, with our audience, saying like there is technical debt. We did start early and there are things that we're dealing with, but you're still finding ways to continue using Kotlin Multiplatform. But from your perspective, do you find Kotlin Multiplatform to be limiting in some areas, freeing in other areas, especially coming from the iOS background?
Yeah. It's definitely very limiting, but limitations can be good. I like limitations sometimes. That kind of forces you to really think about how you want to do things. And part of my idea for Kotlin Multiplatform is, I think probably every company has this problem. If you have like UI, is like the division between front end and back end. Like it's so hard to define that well and enforce it. And I hope every company has this problem. We have it every freaking day where it's like you finish your feature and it's like all of your business logic is in the UI code. And it's like, oh, why did we do that? So with Kotlin Multiplatform, I was like, I'm going to, feed two birds with one stone here. I'm going to create that separation with Kotlin Multiplatform. It's going to be this really clear divide where it's like front end is native, back end is Kotlin Multiplatform. That'll be really simple to enforce. But there was a lot of limitations there, because obviously when the Kotlin gets compiled into your like Objective-C library, there's not a whole lot of expressivity you can get in there. There's a lot of Kotlin features that do not translate at all. And so we had to find a lot of creative solutions where it's like, okay, how do we like create this architectural boundary in a way that is nice to use, not too restrictive, but kind of working within these limitations of Kotlin Multiplatform. And that was definitely tricky. That was like probably one of the hardest challenges to solve initially, but once we solved it, it was kind of smooth sailing from there.
So you sort of come from an iOS background, and very often it's a lot easier for us to convince Android engineers to pick up Kotlin Multiplatform Mobile and give it a try. But how would you approach maybe an iOS developer and encourage them to get started using it, and especially start contributing to the shared code. It's easy to just sort of sit back and let, if it's a cross-functional team and there's an Android developer, just kind of let the Android developer create the shared code. But how do you get them to collaborate and so not just cooperate, but also collaborate in the larger team?
Yeah, that's definitely tough. But it definitely helps that there's so much similarity between the design of Swift and Kotlin. So as long as your developers know Swift, hopefully they're not just doing Objective-C. It's a little bit easier to onboard them because you can kind of look at a lot of the patterns from Swift, and they do largely translate kind of one-to-one to Kotlin patterns. So that's been a pretty useful tool for us. Other than that, like even before Kotlin Multiplatform, we were really big on this. I think it's great in general, but cross-training your engineers is always great. So we have lots of multidisciplinary teams where you have like cloud engineers working alongside mobile engineers, working alongside Linux engineers. And we love sharing that knowledge between team members. So we do a lot of like pair programming and stuff like that as just a way to sort of get your work done, but also be passively training people up on technology they're not familiar with.
Yeah, and also growing their not just growing their skills, but growing their general programming skills, like maybe pairing somebody that is more junior with somebody more senior, or the other way around. And it's interesting, when I was still doing development, as a senior developer, it could be like a little bit of a ego game for you, because you feel like you should know everything. And then a junior developer tells you, like, no, have you heard about this extension function? You're like, no. But that's always great. I mean, everybody can learn something from somebody else. I really enjoy pair programming, and I'm really impressed that you have this sort of company culture to work together and collaborate and sort of pair with and do Kotlin and Swift together. That's really cool. So in terms of, so obviously the languages being so similar, that made it a little bit easier. I'm also learning Swift sort of on the side, and iOS on the side, it's a very good language. But how did you speed up your learning going from Swift into Kotlin? How did you sort of just smooth out those hiccups?
Yeah, it's tough. I think I might have a skewed perspective there. Again, I learned Lisp in my personal time, so I really like learning stuff totally on my own without any help. That's like one of my favorite things to do. So the fact that it was like maybe a little bit rough didn't matter to me so much.
Okay.
Yeah. But for our other engineers, one of my headphones just died. For our other engineers, we do also like build our own trainings. So we build sort of like, it's a cross between like documentation, but also more of like a tutorial where it like walks you through like, oh, if you're thinking about doing this kind of thing in Kotlin Multiplatform, this is like how you would go about doing that, how you would structure it, and the kinds of pieces that you might need in place, and pointing to like examples from our actual code. And that so far has been pretty useful. We've already onboarded, I don't know, maybe like 3 new engineers since we started really using Kotlin Multiplatform a lot. And that seemed helpful for them to have like those explicit training resources in place.
Definitely.
Though we do, I guess you kind of mentioned this before, where it's like that aspect of being like, oh, I'm just going to do iOS and let everyone else do Kotlin. That is a little bit tough, where I don't know if we have a good solution for that, because it's like, if we get someone who's fresh out of college, it's a little bit unreasonable to be like, here, learn Swift and Objective-C and Kotlin all at once, go for it. So we do tend to like, we start people usually on like, if they're doing iOS especially, it's like, just do the iOS for now, like work on the front end, and then we kind of ease them into Kotlin later.
Makes sense. Yeah.
Yeah, and like you said, the Kotlin and Swift are similar. There was even a website that was made a long time ago. Swift is like Kotlin, or Kotlin is like Swift. I can't remember which direction it went.
Yeah.
But as a lot of people ask for, can we have direct Swift interop? You mentioned we're going through Objective-C, and which is a nice thing because it's at least it's similar. It's something that iOS engineers at least used to be used to. I'm sure there's a lot of new iOS engineers who've never touched Objective-C. But what are some things that you've seen that are an issue because of that Objective-C layer, and how are you working around it?
Yeah, there's definitely stuff where it's like, probably the big one would be like sealed classes, where it's like that could almost certainly translate to Swift, but not to Objective-C. So that's one of those limitations where we do a lot of just kind of plain enums. And then the way we work around that is like we'll send like enums through the interface, and then there'll be like public functions where you can kind of pass that enum back if you need to get like more data related to the enum, which is not great, but it works. And I think that's probably the main one. There's certain like types of functions, like function signatures, that could probably be cleaner in Swift, but maybe again, we're not the best example here, because actually we do have a substantial Objective-C code base. And so the whole like Swift Objective-C interop is something we've been dealing with for years. And so the fact that Kotlin shows up as Objective-C, it's actually like, oh, this is not that different for us. So that actually, in a weird way, made our transition smoother almost, because we were kind of used to those sorts of limitations.
And for the interfaces that you're using, like how do you decide whether you're going to be using interfaces or expect actual for these platform specific things, or working around language issues?
Yeah, so the way we've mostly been doing it is there are a few places where we do interfaces. That's the main thing where I guess I never really thought about why we did it this way, but it's like if there's actual like business logic in our native code that we need to talk to, we do it through interfaces. And I think the goal maybe with that is like, ideally we want all of our backend business logic to be in Kotlin. And so an interface kind of makes it more explicit that this is like, oh, this is like a separate dependency that could be fulfilled by any class right now, conforming to this interface. Whereas expect actual, we mostly use that where, the logic is already contained within Kotlin. And so we do have a few places in our code where we have like the stuff where we're like importing the Apple specific libraries and stuff. And we use expect actual in our backend for that, but it's already encapsulated. So I guess I think of it as like, it is just one class, even though it has two separate implementations. So we don't really need an interface in that case.
Okay. Can you perhaps tell us a little bit more about your CI/CD setup at Lutron?
Sure. Yeah. For that, we actually exclusively use Mac build machines for our Kotlin multi-platform stuff. I don't know how rational this still is, but definitely our biggest fear at the beginning with Kotlin multi-platform was like, what if there's a disparity in behavior between the two? And so we really wanted to make sure that our CI builds were going to build for iOS and for Android and test both of them and make sure that all of our tests pass twice, essentially, which might be a little paranoid, but we still feel very nice that happens with every single build. And so that was a little bit hard at first because we never we used Gradle on our build machines before. So it was definitely tricky to figure that out initially, but again, that's one of those things where you figure it out, and generally it's not too bad. Moving on. Probably the more interesting part about our build system now is we're starting to get into things like code generation, actually, where we're generating our Kotlin multi-platform code from certain data files. Like, for example, we have like localized strings, and we want those to be available in certain cases, actually, for our backend. Think of things like translating an error code into like a readable error message. That's like one of the really difficult problems we've had. And now we use code generation through our CI system that like the whole build process understands how to transform like the data through the pipeline and verify that everything's working when it's actually run. So that's been pretty interesting.
Cool. It sounds like you're doing error handling nicely in at Lutron. That's really good to hear. Really good to hear. What made it challenging to set up your CI/CD pipelines? Was there something that, I mean, it is hard setting up CI/CD anyway, but what made it especially challenging?
Gradle. That's it. I have a personal vendetta against Gradle, but we're learning it begrudgingly. Yeah.
How do your Android engineers feel about Gradle? Do they feel the same way?
They fear it. Yeah. I mean, I've never personally met an engineer like in person who was like, oh, I'm like super comfortable doing Gradle stuff all the time. I've never met anyone like that. They're one in a million as far as I know.
Yeah.
Mostly it's copy paste. Copy paste and hope.
Yeah.
There's a lot of that. I read an interesting article about why it's like this for developers and how Gradle, like how it's organically added features over time and how it changes. Like you have to know more about Gradle in order to use Gradle than for some other things, which makes it much more difficult. At Touchlab, we see that too. We've been mainly Android engineers, but now working with iOS engineers all the time. How can we make it easier? Like, do your iOS engineers try to stay away from it, or are they trying to get into it? We're trying to find ways of balancing that need to go into Gradle with, okay, you don't really have to go into it right now.
I have tried to get people into it, but they have resisted. So that's another thing where I kind of identified that as like a weak point, not really even related to Kotlin Multiplatform. Like even our Android app, just like Gradle problems would block us sometimes. And so I really recommend, a big thing for us is like we got our own dedicated mobile app infrastructure team where it's like they just focus on these kind of like internal engineering problems that tend to grind everything to a halt. And that's been really useful just to have people whose like sole responsibility is to improve these kinds of processes. And so that team, I can tell them, hey, you guys got to learn Gradle, and they do. So that's been nice. But in terms of onboarding, that was definitely really painful, especially for me coming from iOS. Like I was the architect, I was in charge of adopting this product, but like I looked at like all the stuff about like, oh, here's how you set up your Kotlin multi-platform project, and it's all just black magic to me. I have no understanding of what any of it is doing. So I do wish, in retrospect, I guess I put us under a little time pressure by like I said, like tying this to a feature we actually wanted to ship to customers. I wish I'd taken the time to learn more about Gradle ahead of time. As much as I dislike it, I'm a big advocate of like properly learning your tools. Like it always sucks to just kind of stumble around randomly with a tool. So I wish I'd set aside like a week or something just to do like Gradle tutorials and learn more about all the specific things, just with like, oh, here's your source sets and here's your repos and dependencies and projects versus builds and like what do these terms even mean. And I think that would have helped a lot with avoiding some of the technical debt we had, especially in our continuous integration pipeline early on. I do recommend, there's a really good YouTube series. Can't remember what it's called, but it's by like an actual Gradle developer. And I think it's just called like Understanding Gradle or something. That was really useful. I watched that pretty recently and that cleared up a lot of my confusion. I wish I'd watched that a year ago. But I think that kind of stuff would have helped a lot. But to a certain extent, it is just unavoidable. Gradle is very powerful. It can do a lot of cool things. It's just a very complicated, confusing tool. And unfortunately, you kind of have to learn it to get the benefit out of it.
Yeah.
I'm curious how your Android engineers feel about Xcode and working in the the iOS ecosystem.
Yeah, I also don't like Xcode, but I try very hard to work around that kind of stuff. Like, I kind of started off actually early on at Lutron working on infrastructure kind of stuff. So like we have like sort of scripts that help you set up with like a proper Xcode environment, and I try to make it as simple as possible. Where like a new Xcode version comes out, I kind of work out all the kinks, make the scripts handle those kinks, and then it's like, okay, everyone rerun the script; it'll fix everything. But definitely, Xcode is kind of a nightmare on its own. Yeah, not fun to resolve build issues with either platform, I guess. Now that I think about it, but at least I don't want to get too into Gradle here on this Kotlin Multiplatform podcast, but it's like the problem is like Xcode is like a fixed pipeline. There's like a fixed set of steps and each step works a very specific way. You can do custom stuff, but your custom stuff is always just like go out to a shell and run some shell script. That's the most you can do in Xcode. Gradle by design is like infinitely reconfigurable. If you load a Gradle plugin, that plugin can do literally anything. Like for our whole like string localization process, like I wrote a custom Gradle plugin where it's like doing all kinds of crazy stuff where it like loads Ruby for reasons I won't get into, and it like uses Ruby to process some stuff and merges that back in and then builds the Kotlin. It's crazy. And so it's just like, that's the kind of like horror of Gradle where it's like, oh my God, I have to understand all this complexity. It's tough.
We've seen that from the Android engineers trying to build on Xcode, like Cocoa Pods. Why do I need Ruby on my machine? I'm trying.
Yeah.
So that goes both ways, I think.
Yeah, that's true, I guess.
Moving into something else now. You talked about the forced separation of the back end from the front end and the UI. At DroidCon London, DroidCon New York City, the DroidCon app was able to have Jetpack Compose running on iOS.
Wow.
How do you feel about that?
I'll be cautiously optimistic about it. I think, like I said, we've been bitten before by stuff like that. So that's the kind of thing. I don't feel bad about being an early adopter of KMM. I feel pretty great about it. That kind of thing, I'm probably going to be the late adopter. Yeah, once it's like Gamma, maybe even version 2. That's when I'll take a look at it. Yeah.
We definitely need to add more letters to our versions, alpha, beta, gamma.
Yeah.
Let's just keep going and going.
Right.
Yeah, that's definitely interesting. You talked about like Flutter, you stayed away from React Native, you stayed away from. I guess Compose on iOS is more like the Flutter, like let's render it on there. Do you see potential like where that could be useful or where you wouldn't want to do that?
I mean, I definitely see the potential for that. So like on the one hand, like, so I do a lot of like video game development in my spare time, and like the idea of like treating your mobile app just like a video game where it's like there's a canvas and you draw to it and you do whatever you want on that canvas is like, yeah, that makes perfect sense to me. Video games can be incredibly performant just as much as any native UI. So there's no inherent problem with that. And I think it's a cool idea. There is just like a big, I guess, UX gap. Like we really highly value our users having like this very intuitive experience. A lot of our users complain about stuff where it's like, hey, the new iOS version came out and your app still looks like iOS 13. What the heck? And like being able to just like really closely follow the native code changes is really valuable to us for that reason.
Yeah, definitely. I can always tell when, or not always, I can usually tell when there's a React Native app on Android that was designed by iOS designers or a Flutter app on iOS that's using material design.
Exactly.
And getting more of those stories from the users, like this doesn't work for me. Why is it like this?
Right.
This definitely would love to hear more of those.
Yeah.
So in terms of multi-platform mobiles, libraries and capabilities, what do you still think is missing? What are you still longing for to see in the ecosystem?
Not much, actually. In terms of like the truly like big gaps in our functionality, like we haven't come up with a solution yet. It looks like all the support is there that we need, frankly.
That's
so
great to hear.
like, yeah, so I'm not worried about it. It's like, it's really just a matter of like time and effort to fill those gaps in using the libraries that seem to be available and stable and broadly used and stuff like that. So that's all great. I do worry a little bit sometimes, like we're using a lot of the experimental Kotlin stuff. I still feel kind of uneasy about that. It's like, I'd love it if that would be stabilized, because without it, there would be huge gaps in terms of like, we do a ton of serialization, and that a lot of that stuff is still experimental, which is really unfortunate, but I'm not too worried about it. We're still moving forward. We're again, heavily investing in this stuff. I think it's going to succeed. I guess I'm not really sure why it's even experimental. It seems to work great. I don't know. But if there are missing features, I don't even know if this is fair to call it, but it's mainly just like the kinds of limitations you get with, in my opinion, the JVM really. I'm not a big fan of JVM languages. Like the way they do generics is very limiting. It's very frustrating, especially coming from like Swift, which has a really nice generic system. I don't know if those things can ever be fixed, because it's just like the nature of the foundation that you're working on. So those I'm happy to kind of like work my way around those issues. But that is the kind of thing that makes me a little bit sad still.
That's really interesting. Because JetBrains and Touchlab, we both want to improve things and listen to the people who are using this, and the people who don't want to use it yet because of certain issues, so that we can continue to improve. Like in the beta announcement for Kotlin Multiplatform Mobile, there is a push for stability in the video that you see on that landing, or the blog post about it. Stability in 2023 is one of the goals. And so what does stable mean to you is something that would definitely help push things in that way. And then from like the interfaces between, this is a JVM language and iOS is not a JVM ecosystem, improving those with like compiler plugins. Touchlab is coming up with a Swift interface improvement tool that's using the Kotlin compiler to improve things transparently. This kind of stuff that we learn and we can build, and we can make this a better ecosystem for everybody.
Yeah, I'm not sure. Sorry, that's my lame answer. It's because I am primarily focused. Like, I love Kotlin Multiplatform for what it helps me deliver to my customers. So that is like my like laser focus right now. I'm interested in how the ecosystem evolves, but unfortunately, like, yeah, it's a tough question. It's like, yeah, what does stability even mean? What has to be in place for that? Even though I say like I want stability, it's mainly because it's like, obviously I don't want something to stop me from delivering value to my customers. But even now I feel like we're already mostly there. Like I said, like, why are these things still considered experimental? We recently updated from, I think, 1.6 to 1.7 for multi-platform, and it was like trivial. There was really no significant changes whatsoever. So I'm not sure what stability means, but I feel like it can't be that far off.
Are you still using the legacy memory model, or did you keep the defaults with 1.7 for the current one?
We do. We're actually early adopters of the new memory model as well. We, like, as soon as that was available, we switched to it, because we do a ton of like parallel processing and background stuff, and we were running into issues. And that was another thing where it was like, I guess that's been generally encouraging, is that it seems like when Kotlin Multiplatform says like alpha, experimental, it's really actually not that bad. It's like pretty stable already, generally works pretty well. We have not experienced kind of like early adopter pain with pretty much anything.
Good to hear. Well, that's the end of our podcast, folks. Max, thank you so much for your time and sharing your story and your expertise with us. I hope that you have a lovely day further, and thank you for coming to speak to us about your journey with Kotlin Multiplatform Mobile. With that, Justin, my co-host, goodbye. Max, bye-bye.
Thank
Everyone
you,
else, have a lovely day.
Thanks,
Bye.